Hey there, kids. Just getting started today with our lesson 6 homework in module 3 for grade 5 Eureka Math. And check your objective at the bottom. Subtract fractions from numbers between 1 and 2. That's what we're doing today. And also, please go watch the problem set video first. It has great notes, and we're talking a lot about the strategies that you can use when subtracting with fractions. And today I'm going to show you mostly just the Common Core way, because the way I used to do it was really tough, and it's so much easier if you use the Common Core way. So let's jump in and get started. For the following problems, draw a picture using the rectangular fraction model and write the answer. Simplify your answer if possible. So hopefully we won't have too much dividing to do, because I want to try to keep things simple right from the get-go. Okay, number 1. When you have 1, you should know that you can use any number to represent 1 as long as you choose the easiest number that's right here, 6. I'm going to use 6 over 6. Okay, any number can be represented in a fraction to show 1. I could use 2 halves or 6 sixths or 7 sevenths. All of those mean 1. Okay, so when you have this other denominator, you need to choose the one that's easiest. Why would you choose something else so that you have to change and make it a common denominator? No, choose what's already there. So when you make your 6 sixths minus 5 sixths, you're going to end up with your 1 sixth. So got to draw a picture of what this would look like. 6 sixths, remember with 6 you're going to make halves and then do 3 on each side. And this whole thing is shaded because we have the whole 1, and then minus 5 sixths, crooked little leg there. And for this one, we already have the common denominator, so you don't really have to worry about laying over the pieces. So we can still do vertical if you'd like. You can still do horizontal if you want. 1, 2, 3, 4, 5, 6. For continuity, since this is what mine usually look like, I would have 5 here. Okay, and so we're going to be taking away 5 of them. 1, 2, 3, 4, 5. So we're taking these off of the whole. That's what subtraction looks like, so that you're left with just this one piece. That's what subtraction is. And so if you have something colored pen, it can be a little bit more fun when you do your subtraction. Anyway, when for B we have an improper fraction, then you have to make your model with more than 1. So let's start out with the model here and show that if we have halves, we would have 3 of them shaded. So here's 1 half, here's the second half, 2 halves, which makes a whole, and then the third half. Now this is what we're starting with when we have to take away the 5 sixths. Now sideways, again, 3 on the top, 3 on the bottom. And we have to take away 5, so same as before. Shade those pieces. Now notice that we don't have a common denominator like we did here in number 1. So you have to make the sixths. Now if I multiply these, or if I lay over my pieces, I'll end up with 12ths. And I can easily do that, so I'll do that here. But I want you to know that you don't have to. You could use 6 as a common denominator and then just not have to change that one at all. But this is the way they like us to do it for now, so I'll lay the halves over here. So now we have 12ths. So we have a whole bunch of pieces that we're working with. So how many we have, of course this is going to be the 12 twelfths plus the other half of 6 twelfths. So that now means we have 18 twelfths. And then if I have 10 of these are shaded out of 12, then I'm going to end up taking away the 10 from the 18. So 2, 4, 6, 8, 10. You can use your pen. Now you can go 1, 2, 3, 4, 5, 6. That's all 6 of them here. 7, 8, 9, 10. And so then here we have 1, 2, 3, 4, 5, 6, 7, 8. That's your answer in the model here. Okay, so that's kind of what the models are trying to help you do, is to see, yes, you can make an equivalent fraction, then you can take away this number of pieces from your whole or your original model. It does say simplify your answer if possible. 8/12 has 2 even numbers, which means you can divide by at least 2. Now, if I was to divide by 2, I would then have more even numbers. So that tells you that there's something larger. Instead of just a 2, you could divide by a bigger number, a number that they both have in common. So what is a number that you could count by and get both 8 and 12? I hope you said 4. So 8 divided by 4 is 2, and then 12 divided by 4 is 3, and that's your simplest form answer for B. So hopefully you got there with your work. And again, all your homework should be done. You should just be checking it at this point. Okay, so here we have 4/3, another improper fraction. So that's going to be 2 blocks or 2 rectangular fraction models, and these are supposed to be divided into thirds. And we have 4 of them, so we have 3/3 here. We have 1/3 here, and that makes our 4/3. And from that, we're going to take away our 5/7. So we have to have 7 pieces. 4, 5. The last line makes 2 pieces, so 6, 7. So we have 6 lines that make 7 pieces. Always remember that. How many are shaded? The top number, the numerator. 1, 2, 3, 4, 5. Now these are not the same, so we have to have a common denominator. So for this one, you can lay over your 7ths and then lay over your 3rds. You can go all the way across if you want at the same time. 3, 4, 5, 6, 7. And then you can change this to your 3rds. So now how many pieces do you have? Well, we're going to have 21 in each one. That's your new denominator. Remember, you can look, basically if you're laying over the pieces like we just did, then you're multiplying these 2 numbers to get your bottom or denominator, okay? Then how many pieces you have in this first number, the whole, is going to be how many are basically multiplied here. 7 times 4. So that's 28, because the whole thing would be 21 21sts plus 7 more. So that's where I'm getting the 28. 7 times 4 is 28, or you can think of it as 21 21sts plus 7 21sts. Okay, now the next one, we had 7ths, but we multiplied it 3 times, which means all the shaded got multiplied 3 times for 15. Now we have a subtraction problem that we can solve because we have a common denominator. So 8 minus 5, there's your 3. 2 minus 1, there's your 1. 13, nice prime number. 21st, and that's your final answer. Can't be simplified, so we'll move on. 1 1/8 minus 3/5. Okay, so for this one, again, many pieces in your model. It'll be so nice when we don't have to do the models anymore. Oops. Gotta have 2 because we have 1 and more. It's just like having an improper fraction like we did on these others. We've got more than 1. So we should divide these into eighths. Remember, half, then fourths, and then take your fourths and split them all into pieces. And that will help you get even eighths. And we have 1 and 1/8, so we have 8/8 here, and then 1/8. From that, you're going to make fifths. Make your pieces a little bit wider and shade 3, or hopefully you shaded 3. Okay, and then to make your equivalent fractions, you have to lay the fraction pieces over. So fifths on the eighths and eighths on the fifths. So 1, 2, 3, 4, 5. And it just makes a ton of little pieces. So good luck with that. Here are your eighths. Started with a half, then fourths, then the eighths. And so how many pieces do you have? Well, you should know you have 40 because 8 times 5 is 40. And if this is 40 40ths, I'm going to have some more, okay? So I've got all 40 40ths plus 1, 2, 3, 4, 5. And this one was not, if you think about it as the eighths across, it was 8 times 3 for 24 because we had 3 pieces and then we multiplied it 8 times. So now you've got a bit of a subtraction problem. Remember just the blah, 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 blah. Remember that it's just the numerators that you're subtracting, and the denominator is like your label. So you should end up with 21 40ths, and hopefully that's what you got on your work. Okay, can't be simplified, so we'll move on. All right, next one, 1 2/5. Whoop. There we go. 1 2/5 minus 3/4. Again, 2 pieces minus 1. The first one is in fifths. 4, 5. 1, 2, 3, 4, 5. We have all of 1 shaded and 2 of the next. And then you've got 3 out of 4 pieces that should be shaded on this side. Now you've got to make your equivalent fractions by laying over the pieces on the opposite side. And fifths over here. You should know that you have 20ths now for both, so we can do our subtraction, but how many do we have? So if I have 20 20ths here, 2, 4, 6, 8, 28 20ths. And then I have 1, 2, 3, 4, 5, 5, 10, 15. Look here, that's where you get that. Do your subtraction, pretty easy. Look at the ones place, take that away. Look at the tens place, take that away. And you have your easy peasy subtraction that can't be simplified. One of the ways that that in the introduction to the video, if you look at taking away just these from your first model or from the whole, if you wanted to have a separate little piece of work over here so that you have what I was talking about in the previous video, so you don't have to do the combination and the one-step subtraction, you just have to remember to put back what you're not using here, okay? So there are, I really prefer, once we get going and you don't have to make these models, I really prefer using this method, just taking this away when you don't have to show this model. Okay, so just know that if you do your subtraction from the whole, taking away the 8, the 15 from the 20, then you do have to put back the 8. And that's where you're going to get your final answer. So it's kind of fun. I prefer doing that. Let me see if I can do that here for you. 6/6 then 6/6 again. So this is all of 1. And then we have 5 more. And we have to take away eighths. Oh, this one would be better if we don't have all the pieces anyway. And we have 7, so we have 7 shaded all the way down to here. Okay, so if I multiplied these, I would end up with 48, but that's a really huge number. So let's take a look at the strategy to find the lowest common denominator. What you want to do is you want to be able to skip count. I usually start with the larger number. So I would say if times 2, that's your scale factor. If 2 times 8 is 16 a multiple of 6? And I would say no, but 12 is. And then 18 is. Is 18 a multiple of 8? No, but 24 is. That's for times 3. So how about times 4? That's where I get 24 for my 6. I now know that I have 24 as my common denominator, which I can then use instead of 48. So if I was to lay these pieces across here, I would end up with 48 pieces on both sides. Now, can you do that? Of course you can. That's what this program is trying to show you with all these models that kids have such a hard time with because it's all messy. And so when we get into the strategy of skip counting, you won't have to have these big ugly models and they won't be so messy. If I wanted to turn 8 pieces into 24, I would simply stripe it with 3 because that's my scale factor. Okay, so now I have 24 pieces here. And if I wanted to turn 6ths into 24ths, I would simply change it by 4 times. That's my scale factor. So I could do halves, and then I could do fourths. And now I have 24 here. Okay, so what's the total number of 24? Well, I can have this. I said I was going to do it this way, so I'll do 24 24ths. And how many extras? So you've got your 1, 2, 3, 4, 5 out of the 6, 5, 10, 15, 20. Now this one we don't have to touch because out of our 24, we have the 1, 2, 3 times, how many do we make? 8. So 7 times 3, so 21. So I can't take the 21 from 20. So we're not going to touch this one, but we can take 21 from 24. This is the way the program will encourage us to go in the future so that I'm only using this. And then it's a pretty easy subtraction problem that leaves you with this. But now is when you have to put back the 20 24ths. So we end up doing addition. That's pretty easy. Instead of doing the huge subtraction. Okay, so you've got some options on these problems. So the first page I did all kind of the old way where you have everything from the whole and you take away this and then you simplify. But this Common Core, this new way, is they're trying to get you to take that big whole from the beginning and then remove what you can from that second fraction. Okay, so I hope that's pretty clear. Anyway, let's do another one. We've got 9/7, so more than 1, minus 3/4. Sorry, that's easier. I'm starting there. 7ths are 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. And we've got 9, so I have 7/7 here. 8, 9. And when you make your model, when you make your model, on this one there's no lower form, so we have to lay across the 4ths and the 7ths. Those aren't super exact, but I think you get the idea. And so we know that we have 28 pieces total. Two, 4, 6, 8. And then we have our 21. 28ths, which we know it's 7 times 3 to give us our 21. And that this one is too big to take from the extra, so we can take this away. I'm just rewriting that. I can take it away from here. And it makes this a very easy subtraction problem. And then we can put back this one here. That's what I'm doing here. I'm doing the subtraction. I'm removing everything I need to, but I'm removing it from the first one that has enough to take away from. And then I put back what I had at the beginning, and that gives me my final answer. Okay? So this is the way that they would like us to go. Finally, we have this last problem. And again, it's more than one. I need to press this so it doesn't tear up my paper. And 2/3, again, starting here because that's easy. And then 12ths, that's just a lot of pieces. And one of the things, okay, I hope this doesn't bother you, but one of the things that I kind of like to do sometimes is, because it would be so difficult to make 12ths this way, I'll actually do more of kind of a fewer pieces with a grid, and then I'm going to use 12 as my lowest common denominator. Why would I do that? Why, Mrs. Setness? Why are you doing that? Because 3, 6, 9, 12. I know that I don't need more than 12 pieces. So let's say I start out with thirds, just like I did here. Okay, but I need to have 12ths. Okay, so how could I make 12ths out of thirds? Well, I could have 4 pieces going the other way. Okay, and so I know that I have all 12 12ths shaded here. Basically, I'm just trying to make 12 pieces. Okay, and I need 3 12ths more. That's how you can tell this is a really long lesson. I need 3 more 12ths. I need all 12 12ths, plus I need 3 more. Okay, now once you have that, remember I got to make my 12ths. So how can I do that? I can do it this way. And I have 8 12ths shaded. So that's my equivalent. So I know this model might bother you, but when we get to this lowest common denominator, you want to have not that many pieces. Okay, should I do this with 36? I could mathematically, but why? Then I'm going to have to simplify it again. Why should I do that when I can subtract 8 12ths from 12 12ths? If I subtract the 8 12ths from the 12 12ths, that will leave me with 4 12ths, which I can then put back with the 3 12ths. And I end up with 7 12ths. And this, I promise, is easier than trying to get 36 36ths and then adding more 36ths and trying to then simplify. So turn this one into 12ths, make a model of 12ths over here, take the 8 12ths away from 12. All right. Whew, almost done. 2-word problems. Sam had 1.5 meters of rope. He cut off 5/8 meters and used it for a project. How much rope does he have left? Sounds like a tape diagram. Always try to put the parts and the whole together. He had 1.5 meters. He cut off 5/8 meter. How much does he have left? The part that was cut off and the part that's left would make up the whole 1.5. Basically what they're saying is take 1.5 and subtract 5/8. Okay, so what can I do? Well, remember, if I have 1, it can be anything. Can it be 8/8? Yes, it can. Can you subtract 5/8 from 8/8? Yes, you can. That leaves you with 3/8. What do I do with 3/8? I put it back with my 1/2. Now I have an addition problem, which is just like a couple lessons ago. Yes, I need a common denominator. 2 and 8 both have 8. What is your scale factor to get from 2 to 8? It's 4. 2 times 4 is 8, so 4 times 1 is 4. 3/8 plus 4/8 equals 7/8. He has 7/8 meter left. So this is kind of where they want you to go without the area model. It's kind of where they want you to go with the subtraction, taking the whole, using a fraction that works with what you're subtracting, and then put it back with the other fraction that you didn't touch. Okay, and I just used the 8 as the lowest common denominator. Okay, now for this one, we have Jackson had 1 3/8 kilogram of fertilizer. He used some to fertilize the flower bed, and he only had 2/3 kilogram left. Kind of like the top tape diagram, but opposite. How much fertilizer was used? So he had 1 3/8 kilograms. He used, and then he had left 2/3 kilograms. And so this time we don't know what was used. Okay, on the top part, we did know what was used. We didn't know how much was left. Now we know how much is left, and we don't know what was used. It's the same approach to this problem. 1 3/8 minus 2/3. Okay, so this time, instead of using the eighths to take away, I'm going to use 3/3. Why? Why would you do that, Mrs. Ennis? Because I want this to be easy. I want to take away. With this denominator, I can turn 1 into anything. So I'm going to take my 3/3 here, minus 2/3, and get 1/3. That's now what's left. I've taken everything away. So I'm going to put back the 3/8 with what I had left. Now here I still have to get a common denominator, which when you multiply 8 and 3, you're going to get 20/4. And when you multiply 3 times 3, this one will change into 9. And 8 times 1 is 8. And that leaves you with 17/24 kilogram that was used in the flower bed. Wah. Flower bed. Okay, so I sure hope this is helpful. I know it's kind of complicated. But we will just keep working on it. How's that? Okay, hang in there. This is just kind of the beginning of the subtraction. We're going to do a lot more subtraction. So we'll see you on the next math video. Hopefully this is helpful. Bye.